Good morning, everybody. In the next little while, I'm going to talk to you about basic symbolic logic statements. We're going to use this form, which is available to you at Canvas, called Symbolic Logic 1. This will just be for notes. The first symbolic logic kind of statement we want to look at is called a conjunction. And you should make this note about that. A conjunction is an and statement. An and statement. There's a symbol for the conjunction. It looks like this. Kind of an upside down V. I think if it had a bar across there, it looked like A, and it would remind me of the word and. But you have to remember that that's the symbol for and. And if somebody wrote a statement like this and asked you to read it, you would read that P and Q. We need to talk about what makes a what makes a conjunction true or false. And we could best do that by making our first truth table. Here's how we'll always do truth tables. Take a careful look here. We'll begin with our premises. I'm going to make a truth table for this simple conjunction. We will begin in alphabetical order with P, and then Q, and then I can do the conjunction of P and Q, and I'll put that as my third column. So I'm beginning a truth table. I have to consider all the possibilities that could happen. Perhaps P is true and Q is true. That could happen. Perhaps P is true and Q is false. That's another possibility. Of all the things that could happen here, another possibility would be that P could be false and Q could be true. And there is one more thing that could happen, and that could be that they're both false. Nothing else could happen. In a logic course, things are either true or they're false if we're going to entertain those thoughts. But now, let us look at the conjunction, the and statement. And what we need to realize is that and statement is true when both conjuncts are true. Actually, in a conditional, good thing to know, the two parts are called the conjuncts of the conjunction. And here, since both of the conjuncts are true, clearly the conjunctional is true. But what about when you have a conjunction and one conjunct is true and the other part is false? Like if I said, I'm a millionaire and I teach math. While I do teach math, I'm not a millionaire, so you'd have to consider that false. And if the other hand, we still have a conjunction, and if this conjunct is false, but the other is true, we still consider it false. And if both conjuncts are false, then it's clearly there's a false statement. Example, I'm from the moon and I weigh 1,000,000 pounds. No, both of those are false and that conjunction is false. So what you need to remember about a conjunction is it's only true when both conjuncts are true. There's a lot more. It's going to get much more interesting. Take a look here. The next one is called a disjunction. And you might have to guess what a disjunction would be. It's an or statement. It'll have a symbol, and we're going to have to agree on how to decide when it's false or true. And the symbol for or is an upside down and. That makes problems for some kids, but that will be our symbol for or. And if I ever wrote a statement that looked like this, you should read that statement as P or Q. Let's make a truth table for this disjunction. And we can decide what makes it true and what makes it false. Or we'll accept some rules about that. Because I would like to compare this truth table with the last truth table, my premises, the P and Q, will take the same form and the same values in the same positions. And that way I can compare the last columns. And that'll be an important decision later as we study more of this. So I'll have a P column and a Q column. And I need to begin just as I began before. And you might notice this pattern. It goes true, true, false, false. And then the second column goes true, false, true, false. And that way you can do those things quickly, but what we should recognize is it gives me one when they're both true, one when this one's true and the other's not. Both of those situations arise and when they're both false. And now I can evaluate the disjunction, the P or Q statement. If I told you my name is Dickie and I teach, P is the statement, my name is Dickie, Q is the statement, I teach geometry, and if both of those were true, you'd say, well, that disjunction would clearly be true. My name is Dickie and I'm a millionaire. Well, I'm not a millionaire, but by golly, my name is Dickie, so that or statement is considered true. Actually, an or statement is considered true when either one of the disjuncts is true. So it's true in the first three cases. However, if both disjuncts are false, we have to consider this disjunction to be false. What you must remember about the disjunction is it's always true unless both disjuncts are false. We'll see more about that in a little bit. There's another form called a negation. A negation is a not statement. In a logic class, a not statement. Because we're doing symbolic logic, there must be a symbol for it. And here's how it looks right there. That symbol means other things in other places, but for the next week or so in this class, this will mean not. And if I said, what does this say? You should read that statement as not P and Q. Interestingly, if I put these three bars, that is to say this statement is equal with, but in a symbolic logic class, they are logically equivalent with, and I'm going to make another statement over here, not P or not Q. These two statements are logically equivalent. And how would I read them is all I care about for right now. This you would read as not P and Q is logically equivalent with not P or not Q. And if you replace P and Q with real world circumstances, I think you see that that's a true statement. But here I'm supposed to make a simple truth table for the negation. And I'm going to do that with just one variable P. And then I can look at what happens with not P. I can decide when it would be true or when it would be false. And I only have two variables. I'd like to make it like these, but I only have one variable. I'd like to make it like these, but since I only have one variable, I can say, well, it could be true or it could be false. But if, thinking with me, if P were true, what about not P? Well, that's the negation of that true statement. Therefore, we consider it as false. And if P were false, the negation of P would be considered as true. Here's another thought. See what you think about this. What if I said not P? Would that be logically equivalent with P? I'm saying these are the same. Not P is logically equivalent with P. Kind of like in algebra, two negations make a positive. It's not true that I don't have homework means I got homework. A couple of things to work on. We're going to look at this section now. And in this section, it says both P and Q are true statements, R and S are both false statements. And I'm going to give the truth value of each of these. And I'm going to do this just as I want you to do it. So let me take a second, set this up. And for each question, I want you to write it down like I'm doing right now. We must remember P and Q are both true as I do this exercise. R and S are both false. And then I can make some decisions about these statements. Here comes the first one. P and Q and R. That's how I would read this statement. And following that, doing number one, I'll go make some substitutions. I know P was true, so I'll just replace that with a T for true. Keep the and. Q was also true, so I'll replace that with a T, and. But now R was false, I'll replace that with an F. So I just made a little substitution. But in symbolic logic, like in algebra, you'll do what's inside the parentheses first. So we should keep this true just as it stands for now. Keep the and as it stands for now. But then replace this conjunction, an and statement, when part is true and part is false. We should know that that would be considered false. And here I have another conjunction. And part of it is true and part of it is false. And since a conjunction is only true when both parts are true, I got to say, therefore, false. Because a conjunction is only true when both parts are true. I'm going to do the second one now. And here's how I want you to do these kinds of things. The second one starts with P or S and Q. I'll make those substitutions. P was a true statement, or S was a false statement, and Q was a true statement. Keep the true as it is, Let's do what's inside the parentheses first. And again, I got another and statement when it's half false and half true. An and statement's only true when both parts are true, so I've got to make that be false. But now look, what kind of a statement is this one? That's an or statement. An or statement, a disjunction, is true if either half is true. Therefore, my conclusion here, this is true. That's pretty much how this game will work for a little while. They probably get much more interesting. I'm going to write down the third one. I'll write it down here. We'll see how it goes. It goes with parentheses open, P and R, or Q or S. In every exercise, you'll write out the statement, then recognize that P and Q are both true and R and S are both false in this case. So let me make those substitutions. P was true, R was false. Showing the steps. It's not how quickly you do it, it's how well you do it. Q was true, or, and S was false. Let's do what's inside these parentheses. Here I have an and statement. When part is true and part is false, an and statement's only true when both parts are true. I got to consider it false. Or, here I have an or statement. Part of it's true and part of it's false. An or statement is true if either half is true. I got to consider that one true. And here again I have an or statement. Half true and half false. Therefore, I have a true statement. And the last one on this page that was available to you at Canvas starts like this one. It says P or R. Nice for you to practice reading them. If we were in class, we'd be saying them a lot. Q or S. P or R and Q or S. P was true, R was false. Make those substitutions first. Then Q was true, or S was false. Or statement is true if either half is true. This one has to be considered true. Doing what's inside the parentheses first. Again, I got another or statement that half is true, so I consider it true. Now I have a conjunction, an and statement, with both conjuncts true, therefore a true statement. And those are the friendly ones. But there's another one I got to talk to you about, called a conditional. Let me tell you about a conditional. It's just another symbolic logic kind of statement. It's an if-then statement. You should make notes on this. This is the most interesting one of them all. An if blank, then blank kind of a statement. And what goes into the first in the first blank there is called the hypothesis. Hypothesis. And what goes in the second blank is called the conclusion. We won't write them this way very often. We'll often write them as a symbolic form. And the symbolic form for a conditional looks like this. How would you read this? You'd have to read this if P then Q. Just for practice, let's look at a more complex statement. This statement is a big conditional. The hypothesis is P and R, and the conclusion is not P and Q. If someone were to read this, they would say, if P and R, then not P and Q. But that's not a statement I really care about right now. That's just practicing reading this. Let's make a truth table to decide when a conditional is true and when a conditional is false. That's rather interesting. We'll do this truth table like we do every other truth table. Start with a P column, and then a Q column. And then we'll do the conditional itself, if P, then Q. We'll always begin the same way, true, true, false, false, because this takes all possibilities into account. And we can decide if other things are logically equivalent, if they're truth and false under the same circumstances. Second column, true, false, true, false. Probably we should think of an example here. Let's say that the conditional, this was to represent, P was the hypothesis. Someone says, I studied. That's what P represents. And Q represents, I get good grades. I get good grades. just so we can make an argument and talk about this, good grades. And you see, in this first instance, the guy walks in the room and says, if I study, then I get good grades. And you see that he did study and he did get good grades. You say, well, he told the truth. That's a true statement. But what if the guy says, if I study, I'll get good grades? He did study, but he does not get good grades. Then you'd say that he told a lie, or that he was false. And that's a time when we would consider the conditional to be false. However, please watch these next couple. Guy says, if I study, I'll get good grades. He does not study, but yet he still gets good grades. This does not argue with the original conditional. We'll have to accept it as true. That's bothersome to some people. Watch the next one. Guy says, if I study, I'll get good grades. He does not study, and he does not get good grades. I do not think that argues with the original conditional. We'll have to consider it as true. What you should remember from this is that the only time a conditional is ever considered false is when you have a true hypothesis leading to a false conclusion. Then we have a false conditional. Strangely enough, a false hypothesis leading to a false conclusion is, in a logic class, considered as a true statement. Here comes a little bit more complex questions. Look at these. In this case, we're going to say P and Q are both true, R and S are both false, but statements X and Y are unknown. We don't know if they're true or they're false. And I'd like to evaluate this. Here we'll do the regular same process. Since P was true, we replace it with a T. Keep that or. R was a false statement, we replace it with an F. Keep this and. S was a false statement. And Y is unknown. I'm just going to use a question mark there. I don't know that truth value, but let me do what's inside of these parentheses. Here I have an or statement. Half of it's true and half of it's false. An or statement is true when either half is true. I got to consider it true. And now here I have an and statement. Part is false and part is unknown. If they were both false, it would be false. If this were false and this were true, it would still be false. An and statement is only true when both parts are true, therefore this must be false. I look back at the whole statement. This whole thing is a conjunction. Part is true and part is false, therefore I have a false statement. I got to consider that as false. I got another one. Again, P and Q are both true. Same suppositions. P and Q are both true. R and S are both false. X and Y are unknown. Let's make substitutions. P was true. R was false. Then, this is a conditional. There's its hypothesis. There's its conclusion. Y was unknown to me, and S was known to be false. I should do what's inside the parentheses first. Here I have a disjunction, an or statement. Half of it's true and half of it's false. I'll consider that to be true. Leading to, now here I have a conjunction. Part of it's false and the other part is unknown, but an and statement is only true when both parts are true. Since this part is false, I got to consider it false. Here I have a conditional. A conditional is false under this circumstances. That's the only time a conditional is considered false, when it has a true hypothesis leading to a false conclusion. Therefore, I consider this a false conditional. In fact, this original statement is a conditional. It has a hypothesis that is a disjunction and a conclusion that is a conjunction, but the whole kit and caboodle is a conditional. Let's do one more together. I think it might be more interesting still. Just one more. Watching me right now. P was true and X, but I don't know about X. So I'm going to put a question mark right there. Then R is false. No, yes, R is false, excuse me. Or X is known to be unknown. I don't know. What could I do about this guy? I didn't like my last example. I don't think it was going to be a good one to show you. So I've rewritten my example number 7. Let's do this one instead. Same premises. P and Q are true, R and S are false, X and Y are unknown. Let's evaluate this. I'll make those substitutions. P was true, R was false, then again R is false, or X is unknown. I don't know. As I go back to evaluate this conditional, the hypothesis is an and statement. Half of it's false. And statement's only true and both parts are true. This must be false. Leading to, now I'm going to check out the conclusion here. Here I have an or statement. If this part were true, but it is unknown, if this part were true, it would be considered true. If this part were false, then it would be considered false. So I do not know the value of this thing. I'm going to leave it as a question mark. The question becomes, can I evaluate this? And yes, I can. The only time a conditional is ever considered false is when we have a true hypothesis leading to a false conclusion. That does not happen here. So interestingly, we have to call this, therefore, a true statement. What you got to remember about that is, this is the only time a conditional is ever considered false. Didn't happen here, therefore this is true.